Hey everybody. Today, you can see the title up on the top of the screen. We're going to go through discussing the equation of a line when in standard form. And so what I've put on the screen right now are your two main forms for the equation of a line. That being, you see the one in purple, or the one identified in purple, the one that you should be comfortable with, slope-intercept form, that is y equals mx plus b. And then what I want to add in today is a new version of the equation of a line, one that's standard form. And you'll notice that one takes the form ax plus by equals k. So just like in slope-intercept form, when we took a look, we knew that the m represented a value, a concept, slope, but it was always a number in place of m, and a number in place of b. Same thing with standard form. Standard form equation has a number in place of a and a number in place of b, as well as a number in place of k. So what I want to do is I want to spend some time just working and getting comfortable with what determines standard form, and then also finishing off today changing back and forth between forms. Okay, let's jump right in. So what you see on the screen right now is you have a big chart and it's got three columns. The first column is telling you that all of those equations are in standard form. They are examples of lines written in standard form. The middle column are lines that are not in standard form. And then what I would like you to do is to try to take a shot at coming up with what are the rules for what determines standard form. So if you take a look at the top row, you have three equations that would all fall under the category, yes, those are standard form. You then have three equations, no, those are not. Could you come up with a rule for why the red ones are not if the purple ones are? And then what I want you to do, try to fill in that rule in the last column. Slowly work your way down every single row, seeing what determines yes it is, no it is not, and then try to come up with the rules based on that. And I think in the end, we could probably do a pretty good job of determining what dictates standard form. Okay, I want you to try that on your own, and then we'll come back and we'll see if we can sum some stuff up together. Okay? So pause the video and give it a shot. Pause it now. Okay, we're back. So if we just looked at the top row, and I'm going to call like the top row A, just to kind of speed up some communication with it, then what I'm hoping we recognized is, well, all of my equations in A seem to have an X, then a Y, then a constant. And notice that that constant is on the other side of the equal sign. When I look at the red column, I'll notice, well, this one starts with Y all by itself. In fact, that equation is slope-intercept. You then have the same thing down here, but the Y isn't isolated. And here we've got the X isolated. So in terms of patterning, I'm hoping that in row A, we could look at that and see that we need to have both the X and the Y on the same side of the equal sign. The constant is on the other. And there's our standard form, or at least one component to it. Okay, if we were able to take that away from row A, great. If we weren't, now what I want you to do is just take a look at the first column, then look at the second column, and notice that that blue does apply. Okay, let's jump into row B then. So if I do the same thing and I call that second row, row B, can we kind of start to play a game like some of these things are not like the other? Some of the things belong. So in the first row or column. You now know both the x and the y have to be on the same side of the equal sign and the constant on the other. You can see that in that first spot, both of those equations satisfy it. Nice. However, you now examine in the second block, and I just put that with writing, and I really want to highlight it right now, that those do not. Okay, so I take a look at two of those equations in particular, and they both have x and y on the same side of the equal sign and a constant on the other, but somehow those don't, or that those two equations are not in standard form. So what makes the red highlighted equations different than the purple? I'm hoping that maybe what you saw in those red equations, and let me just get rid of, that you saw in those red equations, that leading term was negative. And if you notice back in the blue highlighted equations, it's not. So what can we take away from that last column in row B? And let me just get this in orange. The leading coefficient is positive. Okay, I want to draw your attention a little bit to that last equation though. And what I'm going to do is I'm just going to go through and I want to circle that equation, or I'm going to highlight that one in orange. That you may look at that last equation and say, yeah, but like the last equation isn't standard form because there is no x. And I want to make sure that we're good, that not all equations of lines require an x. Our background should tell us that we have plenty of equations of lines that do not contain an x. So if you scan over to the right side, we should be good that y equals 5 is a horizontal line. There is no x. Y does not vary with respect to x. Y is the same thing all the time. So just because there is no x doesn't mean that it's not a line. Just the same as just because there's no x doesn't mean that it's not standard form. The key on row B was that the leading terms were all negative. Okay, I'm going to get rid of my highlight in row B, and then I want you to jump in and try to work your way through C. Now, I could have caught up to a number of people, and so what I want you to do, if I caught up to you, pause the video again, now that you can kind of see the pattern of how we're working through it, and try the rest of those rows. Okay, pause it now. Okay, we're back. So I'm hoping we're taking a look at row C, and same thing. You see that in the column for standard form, those satisfy the two previous rows. X and Y, all by itself, constant on the other side, and leading term positive. So, both satisfy. Okay, what makes those equations different as I move into the ones that do not? Okay, I'm hoping that pretty quick you could have looked at those ones that I just highlighted in purple and said, those ones have fractions. So if those are not standard form and the other ones are, then maybe in standard form means no fractions. And that is correct. You cannot have any fractions when written in standard form. Okay, let's take a look at D. I think we should be good to be able to work our way through D. You take a peek, everything in the first column satisfies what we have. X and Y on the same side, constant on the other. Leading terms positive, there are no fractions. But now you work into that second. Well, there are no fractions in there. However, you notice we have decimals. It's no decimals. And that is correct, that we cannot have decimals in a standard form either. Okay, let me get rid of that. And we should be good to be able to finish off E. Now, I think E is probably the biggest one for us in terms of focus. You take a peek in the column of what satisfies, we're good. X and Y on the same side, constant on the other. Leading term is positive. There are no fractions, there are no decimals. It starts to look good. Then you take a look in that middle column, and if those are not standard form, then what causes the problem? Okay, so what is the wrinkle? Well, I think the way that I would tend to put it, if I were you, if I was making a statement about that last row, is it's the order in which that we write it. And whether you want to write in algebra and say that it has to be X, then Y, then an equals, then a constant, then maybe that's the way you want to write it. But we want our note to be useful for us. So maybe we have to go through and say, if there is an X and a Y. Because let me draw back to your attention. Remember that equation in row B. There doesn't have to be an X there. So if there is an X and a Y within my equation, then what must be the order? So if X and Y exist, then X must come first. And there we go. Okay, I think we're doing pretty good in terms of our order for standard form. And there are all your rules down that right column. Okay, what I want to do is I want to take a look at that maybe a little more formally. So what you see on the screen then is your standard form. And if you take a peek at your equation, this is what we covered on the very first screen. I told you what the standard form looked like. It was ax plus by equals k. What I'd like to do now is to basically answer the question that I put up above that box. What is true about an equation in standard form if it looks like that? So really what we're going to do is we're going to get down some notation to define all the rules we just discussed. Okay, let's take it in its bits. The first thing that we recognized, if the equation is in that form, well, then we already have our x and our y on the same side of the equal sign. Satisfied, we're good. We already have our constant on the other. Satisfied, good. So we don't need to make claims about the order anymore. It's already in that. What we need to start doing is just discussing, okay, what are the specific limitations or requirements on A, B, and K? So let's talk first. Well, I'm hoping that we're good, that A, B, and K have to be an element, and I'm going to put on our formal symbol right now, of Z. Now, I don't think that that number set should be popping automatically into our head. So can we just put in brackets that what we're talking about are integers? A, B, K are an element of the integers. So what that basically requires for that is no fractions, no decimals. Nice. Except you may notice that if I just make that statement, that isn't actually true, right? Integers are whole numbers. That takes care of the no fractions, no decimals, but they're positive or negative. And you'll notice if I chose to make A, B, and K all integers, then maybe I go nice and easy. A is 1, B is 2, K is 3. That equation is standard form. However, if I change that up and I said A is negative 1, B is negative 2, K is negative 3, you'll notice that isn't standard form. It's not that those things were, it's that the A was negative. Remember, to be in standard form, my leading coefficient has to be positive. So I need to make sure then that I make a restriction on the value of A. It's not just that A is an integer, but that A has to be greater than 0, a positive. Now, this is where we got really detailed. Because it isn't just that A has to be greater than 0. Yes, that ensures that my A value is positive, but my A could also equal 0. Okay, let's take a look at what happens if we have the blue. If A is greater than 0, then my A is positive. Fantastic. That's what I needed, a leading term that was positive. So let's examine what happens if A equals 0. Well, if A equals 0, then I'm going to have 0 times x plus, who cares about the rest for right now? Let's look at the consequence of A equaling 0. I'm hoping that we can see that 0 times any number is 0. And so what that ends up giving me is by equals k as my equation. Well, that's still standard form. Remember, not all lines have to have an x and a y in them. If it was, y equals a constant, and I'll just use k to represent a constant, then there's my horizontal line. If it was x equals k, then there is my vertical line. So there is nothing wrong with having the equation by equals k. It just happens to be a horizontal line. So if I were to go back, my A can equal 0. The consequence of that, I'm going to put in brackets in purple. That would make my equation by equals k. Okay, can we see a potential problem then? Can you see a bit of an if-then statement? Notice in those brackets that I just drew, and I'm just going to change the color of that one bracket, that if my A does equal 0, that allows for my B value to become my leading coefficient. And what do we know about all leading coefficients? They have to be positive. So I'm going to have to restrict the value of B. Except I don't have to restrict the value of B if A is Okay, so let's break this up into two statements. So if A is greater than 0, a positive value, then my B and my K are integers. However, if A equals 0, then my B value has to be positive. That ensures that my leading coefficient is positive and therefore standard form. Okay, let me just very quickly go through. Well, what if A equals 0 and B equals 0? Well, pretty quickly, are we good that 0 equals K? And if K is any number other than 0, then that's an untrue statement. And in fact, that is not a line. So we've got a bunch of notation that are sitting there that are talking about us examining, well, if standard form is AX plus BY equals K, then what does that require for the certain values that A, B, and K could represent? I'm hoping that that just gives you a little bit of something to think about, to consider, as we're starting to get into this new notation. Getting used to talking about number sets. Okay, what I want to do now, I want us to get a quick check and see, can we identify an equation and whether it's in standard form or not? Okay, I want you to take a look at the screen. I'm going to go through And what I'm going to ask you to do is circle all of the equations that you think are in standard form. Okay, circle them. Just the ones in standard form. And then we'll see if we match up. Okay, I want you to pause the video and try it now. Pause the video. Okay, we're back. So I'm hoping that we could take a look at the first equation and say, nope, because of that fraction that I just crossed through. We take a look at the second equation, and that should have been a yes. You have your x, you then have your y on one side, your constant on the other, the x comes first, the x is positive, no fractions, no decimals. I'm hoping that we also circled x equals 5. There is no y in that equation, but the x is on one side, the constant on the other. No fractions, no decimals. Same thing with y equals 7. Okay, I think we did well on that first row if we have that. You guys take a look. The second row, no, because the x and y are not on the same side. I'm hoping we circled. I'm hoping we said no, just because, and I'm going to go back to make sure we can see, your y and your x are in the wrong spots. Make sure that those terms are written in the correct order. So that was a no on that one. You can see, oops, we got a negative leading coefficient. No. This one may have caused a bit of a problem, but that is in standard form. Don't be alarmed. The fact that we have that right side, that k value equaling 0, 0 is a value. That's a constant. We're good. And then clearly the last one, no, because of so many things. Okay, if we got to that point where we have those circled, then I think we are doing great. What I want to spend the rest of the time doing today is going through and getting comfortable switching back and forth between forms. So let's take a look at the next section. You see from the instruction at the top, I have asked you to convert. So that is, I want you to change those following lines into standard form. And what we're going to do is we're going to slowly work our way through some common strategies to do that. So let's take a look at A. When we're working our way through A, we need to identify what stops it from being in standard form. And so what I'm hoping is we can recognize that our y and x term are both on different sides of the equal sign. That also then implies that our constant, is on the same side with one of our variable terms. Okay, so what we need to do is we need to rearrange the equation. Okay, you have some options. You could think of getting rid of your plus 3 and subtracting 3. That would then mean that to get rid of your plus y, you would minus y. I just want to write down for us to see this might not be that useful. It does cure one problem, and it's going to give us our purple line, that we would then have a negative 3 is equal to negative 7x minus y, as I do my opposite operations. But you'll notice that that purple line is not in standard form. Now, I didn't create a problem, but if we can recognize that the coefficient on your x term is negative, and it must be positive to be in standard form, we now have to get rid of that negative. Okay, I would hope for a lot of us that then we could say, well, if I need to change the sign of that x term to a positive, then I'm going to change the sign of all of my terms. I think we should be good to be able to come down to the red line and be comfortable with y. If we're not, we need a moment. Just kind of think of it this way. What we did is we chose to divide every term by -1. It doesn't change the number, just changes the sign. Or we chose to multiply by -1. Same effect. Okay, there is a solution for A. That is now in standard form. Notice, My x term comes before my y term, and they are on the same side of the equal sign. My constant is all by itself. Please don't mistake and say, no, wait a second though. You needed to have your 7x and your plus y on the left side of the equal sign. No, standard form doesn't mean that they have to be on the left. They just have to be on the same side. Okay, I want to get rid of that whole solution because I want to give you a different way of thinking about it. So I'm going to erase everything you just saw. And if I was to give a recommendation to tackle that problem, we should be good to finish it in one step. If we recognize that the problem is our x and our y are not on the same side of the equal sign, then rather than blindly bringing your y to the same side as your x, let's focus in on the sign on your x. You can see that the coefficient on your x term is -7. And we know that to be in standard form, the coefficient on our x has to be positive. So in my mind, what I'm going to do is I'm going to picture everything on the left side with my variables. That's going to ensure that the coefficient on my x is positive, and then whatever else happens is just kind of going along for the ride. I will cure the problem of my variables being on different sides and my coefficient of my x being negative all in one step. So to get rid of that minus 7x, I need to add 7x. The y was already on that side of the equal sign. And then I have my constant of 3. One step, all done. Nice. Okay, that's going to be a focus for us as we go, considering the sign on your x term. Okay, let's take a look at b. For us to change that into standard form, we first have to recognize why it's not. And hopefully we can see we've got a similar problem from last time. Our y and our x are on different sides of the equal sign. But we have a new problem. We've got a fraction. Okay, and we know standard form means we cannot have a fraction. So what I'm going to do is I'm going to tackle b in two different ways. I'm just going to circle the y and the x to highlight variables on different sides, and I'm going to keep my 2/5, my fraction, circled to highlight the fraction problem. The two different ways I'm going to deal with this is just prioritizing dealing with one of those problems first. That's all. So let's say that I start off on the problem and I say, my big problem is my variables on both sides, my blue. Then I'm going to prioritize my blue first. Okay, I need to get my x and my y on the same side. Well, I look at the sign of the coefficient on the x, and I notice it's positive. So I want to keep my x term on the same side of the equal sign. I want to keep it there. So that means I'm going to have my 2/5 x, and what I want to get rid of then is the constant that's on that side. Well, to get rid of a -4, I am going to add 4. Now, I'm doing this all at the same time I'm trying to get both my variable terms on the same side, which means I'm going to get rid of my plus y on the left, and I'm going to get a minus y on the right. Okay, if you look back up at the original problem, all I did was eliminate some terms in my original equation. I kind of rearranged it, got some stuff on different sides in order to satisfy the blue. You will notice that my blue equation now, and I should be able to just get rid of that equal sign and make it blue, satisfied the problem of my variable being on both sides. Okay, it still did not fix the red though. Now I got to fix the fraction. Okay, what makes 2/5 a fraction? Well, it's the divide by 5. And we should be good on how to get rid of divide by in an equation. So if we go back to our Unit 3 and we think about how we eliminate divide bys in my equation, then for me to get rid of that divide by 5, I need to multiply every term by 5. I do not need to see the orange. If you are very comfortable doing it, then don't bother writing the orange. Just make sure we don't miss any terms. Okay, so if I multiply every term by 5, then there's my 20. My 5 divided by 5 are going to divide out. So all I am left with is my 2x, and I now have my minus 5y. Okay, you take a peek at that blue equation, and you will notice that that is in standard form. My x and y are on the same side. X coefficient is positive, no fractions. Okay, I'm going to put down an or because I want to tackle that problem by just prioritizing something different. So if we stay with the colors, now what I'm going to do is I'm going to prioritize the fraction. I'm going to focus in on the red. So what if I looked at that equation at the beginning and I said, the red's the problem. I have a fraction. I got to get rid of it. Then maybe, and all I'm going to do is just copy out my equation again, just so we can see how I would affect this in the printed equation. Then what I'm going to do is I'm going to get rid of my divide by multiplying everything by 5. So my first line would now be 5y equals, my 5's divide out, 2x minus 20. Now I would have to say, okay, I cured the fraction problem, but my variables are on both sides. I'm going to picture my y coming over to that side, which means my constant, to get rid of a minus 20, I need to add 20. To get rid of a plus 5y, I'm minus 5y. You'll notice we come in on the same thing. Okay, 2 different ways to go through. Notice they're about equal efficiency. I just prioritized what was the problem differently. Okay, let's take a look at C now. When we take a look at C, I think C should be a check for us, and it should be a pretty quick one. I would hope that we don't have anybody thinking about a moving process. I really hope not. That is, you take a look at C, and I hope that everybody is highlighting that negative on my X as the only problem. Notice your X and your Y are on the same side. There's no fractions or decimals. It's just a negative leading coefficient. So we come back to what we addressed on problem A. You can think in your mind that you are going to multiply everything by -1 or divide everything by -1. The effect of that being, if you change the sign of one term, you have to change the sign of all terms. We come in on that purple equation and we are good. Okay, I'm hoping that that felt comfortable. You'll notice 3 quick problems on being able to go through and change equations of lines into standard form. Okay, so let's try 3 more. So what you see on the screen now is a little bit similar, a little bit different than the previous. But I think we're at a point where we can try some of these problems on our own. So what I want you to do is to give E, F, and G a shot. I want you to try to go through and change each of those into standard form. Do it on your own. Pause the video now. Okay, we're back. So, similar sort of thing to what we talked about before. We could prioritize different things at different times. Maybe what jumps out at me the most about E is my fraction. And so what I may do is I may say, okay, I'm going to get rid of that divide by 4 right now and multiply everything by 4. So that's going to give me a 4y. My 4's divide out. And then I'm hoping we recognize that on the left side, I did not put my variable terms in the correct order. Standard form says Your x term needs to come before your y term, constant isolated. There we go. Nice. Hopefully that one wasn't too bad. Okay, let's jump into F. What do you recognize as your problems in F? Well, I think we got two. Your constant is on the same side. Now, there are alternate forms at times of standard form, and there is one alternate form that says that all your variables can be on one side of the equal sign. That's not what we're dealing with here. But in that alternate form would be the case, that -3 is a problem for us. The second problem, you got a decimal in there. That decimal's a problem, we got to get rid of it. Okay, so how do we tackle it? Well, I think everybody should be good on the -3 part. I'm going to eliminate that from our problem situation. I want to focus in on the 0.5, the decimal. There are a number of ways that you could eliminate that decimal, but there's a couple things I want to work through. Eliminating some decimals are easier than others. That is, I would have a bunch of people that could take a look at the equation given in F right now and say, well, if I have to get rid of 0.5, and I know that I can multiply or divide my equation, then what I'm going to do is I'm going to multiply everything in that equation by 2. Look at the effect. The effect then becomes an 8x, which wasn't the problem, but if I take 0.5 and I multiply it by 2, I get 1. You would then have your -6 equals 0, and then we could fix the -6 problem, but that's not our focus for right now. You just notice in that orange equation, you eliminated your decimal. Okay, I want to talk about why. The reason why multiplying by 2 worked is because if I change my decimal into a fraction, then my 0.5y is really 1/2 y. And I hope everybody can see why a multiplying by 2 would work on my y term, because that would eliminate my divide by 2. Okay, not too bad. Now, here becomes the problem. What if the decimal that I circled, that 0.5, wasn't something so nice and neat? Like, I would expect everybody in here to automatically see 0.5 as fraction 1/2. But what if it was something uglier? Okay, quick review on changing decimals into fractions. We could have done this, and you could have looked at that equation as, well, I know that to get rid of a decimal and turn it into fraction, fractions don't have decimals. So I'm going to eliminate my decimal and write my 5. Now, though, I know all fractions have denominators. So what place value is that 5? It's in the tenths column. We could have went to that as my first fraction. Okay, I'm hoping everybody can see how my green equation is my blue equation if I reduce my fraction to lowest terms. Okay, what if you don't? So what if we don't see it? What if we miss it? I want to walk through what happens if you now go and manipulate the green equation. If you created the green equation, then you should be saying to yourself, I have to get rid of divide by 10s, which means you are now going to multiply everything by 10. Okay, my new green equation becomes 40x. Well, my 10 divided by 10, divide out, nice, there's a 5y. Minus 30 equals 0. And we look at that and we go, great. Okay, now I can cure my problem. I've got the minus 30. To get rid of a minus 30, I'm going to add 30. And we think that that green is standard form. We're correct. That is 100% standard form. But what it's not is simplified. I want you to take a look at all 3 terms you have in the green. And do you notice that there is a common factor of 5 in every single one of those numbers? When we ask you to write something in standard form, it also implies and make it simplified. So what we would now have to do is take each one of those terms and divide it by 5. So 40 divided by 5 is 8. 5 divided by 5 is 1. 30 divided by 5 is 6. And I just want to draw to your attention those 2 orange lines. I hope you see that they're the same if we had finished off the answer in the first orange. So, what is the wrinkle if we tackle the green? If we do not reduce our fraction, then we are going to have to reduce our equation. And that could be a very easy thing for us to not consider or just forget. We forget, we move on, we like the form, oh shoot, I forgot to reduce. So my advice to you, try to reduce as much as you can. As much as you can. Okay, let's jump into G. I think G should have been pretty automatic because it mimics a lot of the equations that we've done in the past. You now have to get rid of both of your fractions. I'll prioritize that first. You have to get rid of a divide by 3 and a divide by 5. I'm hoping that we can see then that the number we want to multiply by is 15. Okay, we're going to simplify first. 15 divided by 3 is a 5. 15 divided by 5 is a 3, and I have no division in the last term. That would allow us to create this purple equation of negative 10x equals 3y plus 60. Now we can see the problem. We've got our x and our y on opposite sides. The x coefficient is negative, so we got to deal with that problem. So I am picturing everything going on the right. Because I read left to right, though, I'm going to put it on the left. But I'm picturing it on the right. So that negative 10x on the right would be a positive 10x. The 3y would still be on that side. But on the opposite side of my equal sign, I have to get rid of my plus 60. I'll have a minus 60. And there we go. Okay, hopefully not too bad. And we're getting comfortable at changing lines from other forms into standard form. Okay, what I want to do now, I want to go the opposite direction. What if I give you standard form, can you convert that back into slope intercept? Okay, here we go. Okay, I think all the work that we've done up to this point, you guys should be pretty capable. At the very least, we should be able to try some stuff. Maybe it's just not our confidence level running too high. So what I would like you to do, I would like you to go through and tackle all 3 of those problems you see on your screen. I want you to convert the following lines into slope y-intercept form, and we'll see if we match up. Okay? Pause the video now. Okay, we're back. So we take a look, and we have to put that in slope-intercept form, which means we need to get our y all by itself. So I imagine in the first problem, a pretty consistent solution would have been we got to get rid of that 2x, which means we need to minus 2x. I don't want that to be in red. And then the 10 was already on that side. Now that we've got the y term isolated, we need to isolate y. So to get rid of a times by 3, I'm going to divide by 3. 2 does not divide by 3 evenly, so I leave it as a fraction, nor does 10. There we go. Okay, hopefully not too bad. If we had a bit of a hiccup on that one, and you think you can make some adjustments for the future for B and C, then pause the video and give those a shot now. Otherwise, we're coming along together. So we take a look at B. This one we may differ on a little bit. And this is where I want to come back to. I look at the sign of my y term. Because I have to get y all by itself, I want my y term to be positive. You'll notice that if I wanted to get rid of that divide by negative 7, multiply by negative 7, I'd have to divide by negative 7. And I want to limit how often I have to divide by a negative. So my idea would be, I'm going to think of that y term on the left side. If I want to get rid of a minus 7y, then I am going to add 7y. But if I can recognize that I'm going to have my y's on the left side, then I really want to get rid of that 5 as well. So on the other side of my equal sign, I'll already have the negative 3x that was there. And now to get rid of the plus 5, I'm minus 5. Okay, you'll notice we have a pretty consistent final line now. Our y term is isolated. Now isolate your y. Divide out your 7. Divide out your 7. There we go. Okay, again, hopefully not too bad. Let's take a look at C, because C might cause an extra wrinkle for you. I just want to make sure that it doesn't. If I was to rewrite C with coefficients, then I'm hoping that you can see that that blue line is the same as the given line. That dividing by 3 is the same as multiplying by 1/3, dividing by 2, the same as multiplying by 1/2, and you now see coefficients on your x and y. So you could tackle that blue equation the same way we did the previous, and get the y all by itself and you're good. I might just move away from that a little bit. Here's why. I'm going to get rid of that blue line, and I'm going to make my focus the same thing that I did in the orange equation. I notice that my y is not by itself, so I need to get it all by itself. And I notice that its coefficient is negative. I don't want it to be negative. I want it to be positive. I'm going to think of my y term going to the right. So to get rid of a minus y halves, I'm going to add y halves. I am picturing my y term on the right, even though I wrote it on the left. What that means then is I have to get rid of that 1 and bring it to the same side as the x. So my x was already on the other side, and now to get rid of a plus 1, I'm minus 1. I think that that is your best first line, because what you'll notice, I've isolated my y term. Now all I have to do is get my y all by itself. And to do that, I have to get rid of my divide by 2. So it actually becomes a pretty easy adjustment. To get rid of a divide by 2, I need to multiply by 2. And as long as I multiply everything by 2, then I'm good. Okay, hopefully those match up. And hopefully we're feeling a little more confident to change into slope-intercept form. Let's try a few more. Okay, you see your screen, and I think we should all be able to work through D, E, and F and use those as a gauge of how comfortable we are with rearranging. So I want everybody, pause the video, give those 3 a shot, then we'll come back. Okay, pause it now. Okay, we're back. So let's focus in on D. I take a look at D. I want to get my y term all by itself, which means I need to get rid of a plus 4x, and I need to get rid of a plus 6. Now I need to get my y all by itself, so I need to get rid of a times by 3, so I divide by 3. And you'll notice I'm not going to write that down, because 6 does divide by 3 evenly. Then I'm just going to do the division. And so 6 divided by 3, 2. If we match up, then I think that that's given you a pretty good feedback as to how comfortable you are with rearranging. Okay, let's work our way through E. You take a look at E. Well, there's my y. I got to get it all by itself. Get rid of a plus x, I minus x, and the 3 is already... Hey, that one was nice and straightforward. Nice. And finally, F. My recommendation would be get the y term all by itself, which means we have to get rid of the plus 2, so we minus 2. And now, to get the y all by itself, I have to make sure that I multiply out, like it's almost this action, multiply out your 4. So I'm going to have a negative 12x and a negative 8, and I am good. Okay, hopefully those things match up with us, and hopefully we're feeling pretty comfortable. What I think we need now is a bunch of practice. Practice at working at rearranging, but the only way rearranging works is if we understand the 2 forms of our equations of lines. Okay, your job, jump in and get some practice. Good luck.